So I wanted to do just a couple more examples from chapter 23 for you. And on this first one is Ruffles potato chips. Students investigating the packaging of potato chips purchased 6 bags of Lay's Ruffles, marked with a net weight of 28.3 grams. They carefully weighed the contents of each bag, recording the following weights in grams, and you're given the data. Do these data satisfy the assumptions for inference? Explain. So I started off, I wrote these down as I was reading the problem. We are not told the bags are randomly selected, but I'm going to make the assumption that the bags are representative of the population of all the bags produced. Secondly, since I'm making that assumption, the bags should be independent of each other. The third thing, the 6 bags, definitely less than 10% of all bags of chips. And then the normality, I did a stem plot. Now, I did a split stem plot. I think it's the easiest plot to do with a small data set, which means the 28 point, anything from 0 to 4, 28.0 to 28.4 would go on that stem. 28.5 to 28.9 would go on the next stem. 29.0 to 29.4 would go on the next stem, and that's all I needed. I didn't bother putting the stems in order because that's not really my goal here. My goal is just to show a rough graph there to show that it is approximately normal, and it seems like it is. So the conditions are met, which means I need to name what I'm going to do, create a 95% confidence interval. I did not name my interval. However, I did use the formula, and that would be allowed, so it would be okay. But if you don't use the formula, then you need to make sure that you say you are doing a 1 sample t interval for the mean. That's the procedure that we are doing. So I used the formula because I wanted to kind of talk a little about that on here. When you go through to do the confidence interval, I use the t star value with 5 degrees of freedom. Remember, the degrees of freedom is n minus 1, so n was 6. So if you look on your yellow sheet, and it is on the side, because you have to be 5 degrees of freedom, and we're doing a 95% confidence interval, which means the tail is split on both sides. So you're looking at the top of the column, it should have 0.025 for the tail probability, and go down to 5 degrees of freedom, and you should find the 2.571. So this is the formula that I would use. It's the sample statistic plus or minus the critical value times the standard error of the statistic. And for means, it is the standard deviation divided by the square root of n. So I plugged in those values, and I got this confidence interval. Then what I did is I also did it on my calculator. Oh, I jumped to part C. Sorry, we'll go back there. But on part C, when I did that, I went ahead and did the interval. I do have to go back to part B. I put all the data in L1. So I put these 6 bags, the weights, in L1. Then I did 1 variable stats. So just, you might want to review that. And when I did, I got the value for x bar and the value for s sub x. Then I could have just used those. I did here. I used those values in my formula. But when I went back to the calculator to do, notice it says t interval. That's what you're going to choose. And when I did that, I actually used the data because I had the data in L1, and I did 95% confidence level and then calculate, and I got this. Now notice it's slightly different. Not much, but actually this one would round to 29.21 and mine didn't. But this is more accurate, the one on the calculator, because I did not use rounded values like I did up here. I rounded x bar when I plugged it into my formula. Either way, doesn't matter though. If you did it by hand and you rounded, fine. If you use your calculator, fine. But then, of course, it's very important that you interpret correctly. I am 95% confident that the true mean weight of the Lay's chip bags is between 28.36 grams and 29.2 grams. So that would be my interpretation of the confidence interval. And then part E asked to comment on the company's stated net weight of 28.3 grams. Since the entire interval is above the stated weight of 28.3 grams, we have evidence that the company overfills the bags. But you know what? Nobody complains about that one. However, if they underfilled the bags, that would be an issue. So hopefully you see the details that I included in that and the communication involved in your interpretations. That's very important. The next problem I wanted to do was problem 31. One of the important factors in auto safety is the weight of the vehicle. Insurance companies are interested in knowing the average weight of cars currently licensed in the United States. They believe it is 3,000 pounds. So immediately I knew if that's what they believe, that's my null hypothesis, status quo. To see if that estimate is correct, they checked a random sample of 91 cars. So I make notes over here. N is 91. For that group, the mean weight was 2,919 pounds with a standard deviation of 531.5 pounds. So that they're giving me all my sample statistic. Is this strong evidence that the mean weight of all cars is not 3,000 pounds? That tells me I'm doing a two-sided test. So I have my null and my alternative hypotheses. I wrote some words down, just what this meant. The average weight of cars in the US is 3,000 pounds, so I remember the context. They didn't say check my conditions, but you can't do a test without checking conditions. So I'm told it's a random sample. You can look back up there and see, random sample of 91 cars. Since it's random, the cars should be independent. 91 is definitely less than 10% of all cars in the US. Now, we don't have data to check the normality. I can't make a graph, but n equals 91 is large enough. Remember what we're allowing to do. That means the central limit theorem kicks in, and we're allowed to use an approximately normal model. But remember, when we're dealing with smaller sample sizes, even with 91, we have to use the student t distribution, not z. With means, we never use z. We always use t. So state your test. I'm going to do a one sample t-test for the mean. And really, when you say t-test, you should talk about for the mean. Remember when we did a z-test, we called it a one proportion z-test. So we used the word proportion. So if you just say a one sample t-test, you're really not talking about the mean, so you really should say that. So what I did not do this by hand. I cut and paste the calculator screenshots for you. So I entered the information. I'm using stats for this one, and I entered that information. Remember, I'm doing a two-sided test. So then what do you write down? Well, you need to write down your test statistic, which is t. Notice that you are not told anywhere in here that you have 90 degrees of freedom. You have to know that because it should be there. So when you write down t equals negative 1.45, you need to write down 90 degrees of freedom. And I usually just do it like this because that's commonly understood. If instead you wrote something like, if you did not do this, instead of this right here, if you just said degrees of freedom equals 90 and you didn't put it there, that's okay. That wouldn't matter. Then your p-value is 0.1495. So that's really what's critical. You want to make sure you write that information down. And then you want to make sure you give a conclusion in the context of the problem with a high p-value of 0.1495. We do not have evidence to claim that the average weight of cars in the US differs from 3,000 pounds. And I put a note, and you need to remember this. You cannot say that the average weight is 3,000 pounds. We can't accept the null hypotheses. All we can say is we don't have enough evidence to say that the alternative is true. That's all we can say. Now, they did not ask for an interpretation of a p-value, so I didn't give one. If you were asked for that, what does a p-value mean? It's a conditional probability, and it means if the null hypothesis is true, if the average weight of the cars in the United States was 3,000 pounds, then the probability of getting a sample as extreme or more than ours is 0.1495. That is not that unusual. So we don't have enough evidence then to accept that alternative hypothesis. So hopefully that helps. And I hope that you see the similarities to proportions when you're going through the specifics of this, other than make sure you are using the right symbols because now we're talking about means.